Alright, y'all. If you hadn't already, please grab your 3-ring binder, and in your Chapter 4 table of contents, today's date is April 10th, and we are multiplying polynomials, part 2. So we're going to wrap up multiplying polynomials today. It's going to build off of what we did yesterday. So once you get that in your Chapter 4 table of contents, also put your name and today's date on your notes. So, building on what we did yesterday, let's use the distributive property to multiply a monomial term to a polynomial term. So for number 1, 4x times 3x plus 1. We've got to multiply 4x to the 3x. That's going to give us 12x squared. The 12 comes from 4 times 3. The x squared comes from the fact that this was x to the first times x to the first, and you add those exponents. Then 4x times 1 is just 4x. Your answer is 12x squared plus 4x. Next up, negative 3x squared times 4x plus 2 minus 3x. So we're going to distribute negative 3x squared to the 4x and to the 2. Negative 3x squared times 4x is going to give us negative 12x cubed. Negative 12 comes from negative 3 times positive 4. The coefficients multiply to give you negative 12. The x to the third power comes from x squared times x to the first. 2 plus 1 is 3. Then, negative 3x squared times 2 is going to give us negative 6x squared. Now be careful. Whenever you've got an expression like this where the parentheses end and then there's more, you don't multiply negative 3x squared to the negative 3x. You just bring that on down. And that's it. There's nothing else to combine or multiply or add, subtract, nothing. So our answer is negative 12x cubed minus 6x squared minus 3x. Okay, in this lesson, we're going to continue using the distributive property, but we're going to be multiplying two binomials together. So, instead of just 4x times this binomial, we've got a binomial times another binomial. Now, we'll keep on using the distributive property, but except this process requires distribution twice, also known as double distribution. So how this works is I've got to treat this like 3x times 2x minus 1, and I've also got to treat it as 4 times 2x minus 1. So again, I've got 3x times 2x minus 1, and I've also got 4 times 2x minus 1. That's all this really boils down to. And then distribute the 3x times 2x, and 3x times negative 1. Well, 3x times 2x is 6x squared, and 3x times negative 1 is negative 3x. And then distribute the 4. 4 times 2x is 8x. 4 times negative 1 is negative 4. And then, most of the time, you're going to end up with a pair of like terms in the middle that can be combined. Negative 3x and positive 8x. Now 6x squared doesn't have anybody to combine with, so you can just bring it on down. Negative 3x and positive 8x are going to add to negative 5x, or excuse me, positive 5x. Positive 5x. And then that constant negative 4 also doesn't have anybody to combine with. So your answer is 6x squared plus 5x minus 4. Now I'll go ahead and say that this first thing that I wrote down, 3x times that and 4x times, or 4 times all that, usually people don't write that. They skip this step because usually what I see instead is people just do it like this. 2x times negative x is negative 2x squared, and 2x times 3 is 6x. And then negative 5, don't forget the minus sign in front of the 5, times negative x is positive 5x. And negative 5 times 3 is negative 15. So they skip that middle step there, or that first step, and just go straight to distributing the first number over top and the second number, and just draw the arrows down below. But next part is always the same. Combine those like terms if you can. Our final answer here is negative 2x squared plus 11x minus 15. Number 5, 4x plus 5 times 4x minus 5. So, start with the 4x. 4x times the other 4x gives us 16x squared. Then 4x times negative 5 is going to give us negative 20x. Then I've got that positive 5 to distribute. 5 times 4x is positive 20x. And 5 times negative 5 is negative 25. So this one's kind of a unique situation because whenever I go to combine those like terms, negative 20 and positive 20 add to 0, and so those just cancel each other out. And your final answer here is just 16x squared minus 25. That's a special pair of binomials that, because it's 4x plus the number and then the same thing minus the same number, because it's the same thing plus the same thing and then minus the same numbers, the middle terms end up canceling each other out, and so we just have 2 terms as our answer. Okay, take a few minutes and try 6, 7, and 8. I'm going to give you about a minute per question before I go over them, so go ahead and try number 6. Okay, for number 6, 4x times 3x is 12x squared, and 4x times negative 1 is negative 4x. And then distributing the 1 times 3x is 3x, and 1 times negative 1 is negative 1. And then there's some like terms in the middle. Negative 4x and positive 3x add to negative x. You could put the 1 there if you want. So your final answer is 12x squared minus x minus 1. Okay, we'll go over number 7 here in just a second. Okay, number 7. Negative x times 5x is going to be negative 5x squared. And negative x times negative 1 is going to be positive x. So negative 1x times 5x is negative 5x squared, because negative 1 times 5 is negative 5, x times x is x squared. And negative 1x times negative 1, the negative 1's just multiply to positive 1. Then distribute 3. 3 times 5x is 15x. 3 times negative 1 is negative 3. And then combine your like terms in the middle. Positive 1 and positive 15 add to positive 16x. And so I've got negative 5x squared plus 16x minus 3. If you've not worked ahead to number 8 yet, be careful on this step where you combine the like terms, because these two binomials, one of them is written in kind of a weird order. So just be careful and work through number 8, please. Okay, for that last one, distributing 3 to negative 3x gives us negative 9x, and 3 times negative 1 is negative 3. And then distributing negative x to negative 3x is going to give us positive 3x squared, and then negative x times negative 1 is positive x. We've got to be careful here because our like terms are not in the middle, they're actually on the edges. I've got negative 9x and positive 1x. Those are going to add to negative 8x. To have this in standard form, I'd want to have the 3x squared up front, and that minus 3 on the back. Okay. All right. So, jumping on down. Sometimes instead of multiplying two binomials, the question will require you to square a binomial. This is not any different than the examples above, it just looks different. But whenever you're squaring something, all you're doing is multiplying a binomial by itself. So, number 9, when it says 5x minus 1 squared, it's really asking me to say 5x minus 1 times another 5x minus 1. And once I rewrite that, it's the exact same thing as what I've got going on up here. 5x times 5x is 25x squared. 5x times negative 1 is negative 5x. Negative 1 times 5x is negative 5x again. And negative 1 times negative 1 is positive 1. There's some like terms to combine here. Negative 5 and negative 5 make negative 10x. And so our final answer is 25x squared minus 10x plus 1. Be really careful, that last line. While it is tempting, never distribute the exponent to the terms of the binomial. X plus y squared does not equal x squared plus y squared. This is the most common mistake, okay? People will say, well, that's just x squared and that's just y squared, and then they'll get it wrong. For example, if I distributed the 2 to the 5x to get 25x squared, well, that looks good. and then distribute the 2 to the negative 1 to get positive 1, suddenly I'm missing the minus 10x. That never works. Don't do that. Okay? Try number 10, please. I'll go over this in just a moment, but if you need more time, you can pause the video. All right, again, I'm going to write this twice and say 3x plus 4 times another 3x plus 4. Distribute 3x to 3x to get 9x squared, and 3x to 4 to get 12x, and then distribute 4 to 3x to get another 12x, and 4 to 4 to get 16, and then combine the like terms in the middle. 12x and 12x are going to add to 24x. So your final answer is 9x squared plus 24x plus 16. Now you may notice a pattern here that both times the middle two terms that you combined were the exact same thing. Whenever you square a binomial, that will happen every time. And if you're looking, 5 and negative 1 contribute to that negative 5. 3 and 4 contribute to that 12. There is a pattern there. I'm not going to talk too much about it just yet, but if you see it and you think you can do these a little bit quicker, go for it. Okay, let's flip our papers over to the back side. Here, these are going to be a little bit harder, because you can see we're multiplying a binomial, meaning something with 2 terms, and a trinomial, meaning something with 3 terms. 4x minus 1 is the binomial, 2x squared plus 4x minus 1 is the trinomial. We need to carefully distribute each of the 2 terms in the first binomial to all 3 terms in the second binomial. In total, there are 6 things to multiply all together, and then you still need to combine some like terms. So, how I'm going to do this is just start with the 4x and ignore that negative 1 for a second, and say 4x times 2x squared, which is 8x cubed, and 4x times 4x, which is 16x squared, and 4x times negative 1, which is negative 4x. And now I'm going to pretend that 4x wasn't there and instead use this negative 1. Negative 1 times 2x squared is negative 2x squared. Negative 1 times 4x is negative 4x. Negative 1 times negative 1 is positive 1. So these are my 6 products whenever I multiplied and distributed all these out. Looking through that, there are some like terms. I've got a 16x squared and a negative 2x squared. And I've also got a negative 4x and a negative 4x. So, when I combine my like terms, my final answer is 8x cubed, 16 and negative 2 make 14, x squared, negative 4x and negative 4x add to negative 8x, and then that plus 1 hanging off the end. So your final answer is 8x cubed plus 14x squared minus 8x plus 1. Now, there's a lot going on here, and if it makes it easier, You can kind of treat it like we did that very first double distributing question by rewriting it and then using the distributive property. So I'm going to let you try number 12. But if it helps you keep track of everything, because it's so easy to miss something in here, you are welcome to write it like this instead. 3x times all of that plus 2 times all of that. If writing it out like that helps you any better, go for it. It's the exact same thing. It'll get you through the exact same process, but it might be just a little bit more organized. So take a moment and try number 12, please. Pause the video if you need a little bit more time. So if I distribute 3x to 5x squared, I get 15x cubed. 3x times negative 4x is negative 12x squared. And 3x times 3 is 9. Then distribute the 2. 2 times 5x squared is 10x squared. 2 times negative 4x is negative 8x. And 2 times 3 is 6. Just like before, there's some like terms we can combine. I'll go ahead and write the 15x cubed up front because there's nothing to combine it with. Then I've got negative 12x squared and positive 10x squared. Those are going to add to negative 2x squared. And I just realized I missed something. 3x times 3x is 9x. I forgot to write the x there. Speaking of that 9x, 9x and negative 8x add to 1x. If you want to write that 1, you're totally fine to do so. And then carry on over the plus 6. So again, just make sure you catch up with my little mistake here. When I distributed 3x to 3, I forgot to write the x with that 9 at first, but that's a 9x. And that just kind of hammers home the point that even me, your math teacher, sometimes, whenever I'm doing these, loses a little piece of something in all of this chaos. So, the reason I say all that about how hard this can be and how ugly is sometimes it's just hard to stay organized. So I want to show you a different way of completing these questions, which is called the box method. It helps you organize all of the multiplications so that you're less likely to lose stuff. So how this works for number 13, again, number 13, you can do it exactly like what we did up here. Totally fine. But a different way of doing this is if I'm multiplying 2 terms by 3 terms, I'm going to draw a 2 by 3 grid. And then on one side, I'm going to write this 2x plus 3. And on the other side, I'm going to write this 4x squared minus 5x minus 6. And in each of these grid boxes, all I need to do is multiply the label on the side by the label above it. So 2x times 4x squared is 8x cubed. 2x times negative 5x is negative 10x squared. 2x times negative 6 is negative 12x. This is essentially the same thing as me distributing this 2 to the 4x squared, the negative 5x, and the negative 6. Then, essentially the same thing as distributing this 3, multiply 3 by all of these. 3 times 4x squared is 12x squared. 3 times negative 5x is negative 15x. And 3 times negative 6 is negative 18. So that keeps track of all 6 of the multiplications that I needed to take care of. I still need to combine like terms, and the nice thing about this is the like terms are always diagonally connected. I don't have anybody to combine the 8x cubed with, or the negative 18, so those are the two terms just like before that I'll just carry straight on down. So my final answer is 8x cubed plus 2x squared minus 27x minus 18. Now again, if you were totally fine with the previous method of using the distributive property a bunch of times in a row, that is totally fine. This just kind of helps you organize the distributive property, but it is the exact same thing. I wanted to show you this box method because for number 14, we're multiplying 3 terms by 3 terms. So I would draw a 3 by 3 grid. That's because in total there are 9 multiplications that I would need to do here. And drawing the arrows all over the place for 3 different things to distribute does get a little bit hard to follow. And rewriting this way gets to be a lot to write. So maybe this box method is a nice way to handle these larger, harder problems. On the side, I'm going to write 2x squared minus x minus 1. And along the top, I'm going to write x squared minus 3x plus 6. And honestly, it does not matter which side you write each of these polynomials on. You could have written x squared minus 3x plus 6 down the side, and 2x squared minus x minus 1 across the top. Does not matter. Okay, I set it up for you, but I want you to try this one out on your own. So, try finishing up number 14, and we'll go over it here in just a minute. Alright, we're going to go over this in just a second, so pause the video if you need more time. Okay, so on this top row, this is essentially me distributing 2x squared to all three of these. 2x squared times x squared is going to be 2x to the fourth power. That's 2 times 1 is 2. X squared times x squared, add those exponents to get 4. 2x squared times negative 3x is negative 6x cubed. 2x squared and positive 6 multiply to positive 12x squared. Then negative x, which remember that counts as a negative 1. Negative 1x times x squared is negative 1x cubed. Negative 1x times negative 3x is positive 3x squared. Negative 1x times 6 is negative 6x. Okay, now distributing the negative 1. Negative 1 times x squared is negative x squared. Negative 1 times negative 3x is positive 3x. Negative 1 times 6 is negative 6. So there were 9 multiplications that I had to do there. I feel like treating it with this box method did make that a little bit easier for me to not miss anything. And now I need to combine like terms, and again they're conveniently kind of diagonally connected. Negative x cubed and negative 6x cubed, negative x squared and 3x squared and 12x squared, and 3x and negative 6x. So our answer, this massive looking answer, is 2x to the fourth power minus 7x cubed. How would I get the 7? Well, negative 1x cubed and negative 6x cubed add to negative 7x cubed. Then negative x squared and 3x squared add to 2x squared. Add that to the 12x squared to get 14x squared. Then 3x and negative 6x are going to add to negative 3x. And then bring on down that minus 6. Okay. So the good news is that is probably as hard as it can possibly get for a Math 1 level. Okay? The better news is the most common type of question you're going to be asked is not either of these, but more like these up front. So, if this seemed kind of brutal, because it is, just know that, yeah, you should be able to try to do it, but you're not going to be hounded with these types of questions over and over and over again. It's more or less going to be these. So if you're good with these, you're probably good. I do have one more question for you. And of course it's a word problem. And I want to really star this one because this is an excellent example of an EOC style question. Okay? So, the dimensions of a rectangular pool that is surrounded by a rectangular tiled patio are shown below. Write a polynomial expression to describe the area of just the tiled patio. So, all it wants in terms of the area is this tiled patio. In other words, just the outer ring around the pool, but not including the area of the pool itself. So to answer this question, first I need to figure out the area of the entire thing. So that would be 5x plus 1 times 3x plus 2. So I'll go ahead and double distribute that. 5x times 3x and 5x times 2 are going to give me 15x squared plus 10x. Then distribute the 1. 1 times 3x and 1 times 2 is going to give us 3x plus 2. And then combine like terms in the middle to get a final answer of 15x squared plus 13x plus 2. But that is the area of everything, not just the tiled area. That's the area of the pool and the tiles. So the next thing I need to do is figure out the area of the pool. Well, the area of the pool is 3x plus 1 times x plus 5. So let's double distribute that to figure out an polynomial expression for the area of the pool. 3x times x is 3x squared. 3x times 5 is 15x. 1 times x is 1x. And 1 times 5 is 5. Combine those like terms in the middle to get that the pool's area is 3x squared plus 16x plus 5. Okay, so if we want the area of just the tiled patio but not the pool, all we need to do now is subtract the area of the entire figure minus the area of the pool. That'll leave the leftovers surrounding the pool. So I'm going to write 15x squared plus 13x plus 2 minus 3x squared plus 16x plus 5. Remember, when you're subtracting, you've got to subtract each of these individually. So 15x squared minus 3x squared is going to give us 12x squared. 13x minus 16x is going to give me negative 3x. And 2 minus 5 is going to give me negative 3. So our final answer for just the area of that tiled ring around the pool is 12x squared minus 3x minus 3. So, talking about EOC style questions, they love to ask geometric style questions that involve not just the algebra that we're doing, but also some geometry with area, perimeter, volume, those types of things. So, just read these types of questions carefully. They're not meant to be super tricky, I don't think. They're meant to just tag in a bunch of different maths all at once. Okay, so we're done with notes. So you can go ahead and put this paper in your binder in chapter 4. And here in a second, you can put your binder back on the shelf, but stay seated for just a second. Up next is another little Delta Math assignment. Again, just like yesterday, I've cut it kind of short so that it should not take you the rest of this class period. Okay? If you finish early, you have time to work on your test corrections. Those test corrections are due Friday at 3 o'clock. I am purposely trying to give you time to work on those test corrections if you need to do so. All right? If you need to borrow a computer, you can borrow one from your sub. Just ask for it in the little green box behind them. And just make sure that those computers stay in this room. Y'all check Canvas for the assignment and have a wonderful rest of your day. Please behave, and I'll see you tomorrow. Bye.